All right. Hey everyone. So for this video, we're kind of switching gears now. We've talked about data collection, we've talked about some data graphics and some data summaries, but now we're going to start talking about sampling distributions and confidence intervals. But even before we get to these topics, which are really the main focus, we're going to spend a little bit of time talking about the normal distribution. And so the normal distribution is one of the most kind of important things in stats. And there's a picture of it here. And so the shape of the normal distribution is just this nice kind of bell-shaped curve. And so there's many different types of distributions in stats. Um, we're not going to talk about any of them, but you'll notice in our textbook that a bunch of them are in the chapter with this normal distribution. So there's like binomial, uniform, I think they do geometric, and all of that is a little bit more theoretical. And so this class is applied stats, so we're trying to keep it as applied as possible. But even with that, there's just no way around us having to go through this normal distribution. We'll see why it's so useful a little bit later. Okay, and so we could start by just answering a little bit more explicitly about what a distribution is. And you could kind of think about a distribution as just being like a smooth curve through a histogram. And so something like that, you could almost, it's not exactly technically correct, but you could kind of interchange the histogram and this distribution. They really kind of mean the same thing. So just like for a histogram, this smooth distribution curve is going to have a shape. This shape is symmetric. It's going to have a center at about 40, and it's going to have like a standard deviation. And so I would guess that that would be about, I don't know, like 7 or 8-ish. And so it's going to have a lot of the same kind of characteristics that we talked about with histograms. And so let's go through some of those a little bit more explicitly. And so in particular, we're going to talk about this normal distribution. And so a normal distribution, its shape, like we just mentioned before, is going to be symmetric. We also talked about modality, so unimodal versus multimodal. We see just the one prominent peak, and so it's going to be unimodal. And it's also often just described as bell-shaped. To be honest, I still just don't see the bell. Like, I guess if you squint really hard, it kind of looks like a bell. But I don't really get it. So it just kind of looks like this kind of nice smooth curve, and we're gonna just call that bell-shaped, even though it doesn't look like a physical bell, at least to me. Okay, so take a second to pause the video and think about these two questions about whether we should use the mean or median as our measure of center, and whether we should use the standard deviation or IQR as a measure of spread if we have a variable that's normally distributed. Okay, so this is kind of a little bit of a review, but we would end up using the mean as our measure of center and the standard deviation as the measure of spread. And so why? So just because there's no extreme skewness. All right, and so this normal distribution we can describe just by using two different numbers, and we're going to call those numbers parameters. And so all parameters are, as it sounds kind of like a more complicated thing that it is, it's just numerical characteristics of a distribution. And so we're only talking about the normal distribution in this class. And so we just kind of have to remember that the normal distribution has two parameters. It's got a mean, which we're going to denote as mu. And so mu is a Greek letter that just kind of looks like a cross between a U and a capital M, kind of ish. I don't know, kind of grasping at straws here. But this is just convention, what everyone in stats will refer to the mean as, and a standard deviation. And that is denoted as sigma. And so I'll write out kind of the pronunciations a little bit. So that's sigma, that's mu. And for all the Pokemon fans out there, the many, many, many of you, you say it just like the Pokemon, Mew. And so these are just numbers. So the mean might be 50, the standard deviation might be 3. So all these are two numbers that we could use to describe the normal distribution. So our shorthand notation, so the normal distribution is often kind of written like this. So this is kind of the distribution symbol, an N for normal. And then in parentheses, you would give the mean and the standard deviation. So again, these are just, these are like real actual numbers. So if you jump to the bottom of the page, in this baby weight example, the mean baby weight is 7, the standard deviation is 2. And so you would write this as normal 7, 2. All right, so that's jumping ahead a little bit. And then we've got this final kind of note about the area under the normal distribution curve. And so we're just taking this as fact that the area under the curve of any distribution, not just the normal distribution, but any, is always equal to 1. So we're taking this as fact. We'll reason through it a couple videos from now when we talk about how to find probabilities using this normal distribution curve. It'll make a little bit more sense then. For now, we're just taking it as fact that if you kind of shade this entire area, then that would be equal to 1. All right, so that's going to kind of wrap it up for this video. In the next video, we'll kind of practice drawing a normal distribution, and then we will kind of do some practice with this baby weight example a little bit as well.